All right, here is a video for day 9, assignment number 1, our little video notes on the solving quadratic equations. I'm going to move to this page. Here's your 2 blank ones. You could print out a copy of it and do the work right on it if you want to, or you could just write these on your own paper and put it on your own paper and then take a picture of it, attach it to Google Classroom after you're done. What I'm going to do is look at the 2 answer keys and kind of walk you through them, add a few things of my own, so you can kind of see how to do each of the 5 methods. There's 5 different methods to solving quadratics, 5 ways to attack it. So one way to attack it is factoring. So factoring means you want to break it into smaller pieces. So they're taking this big 3-piece thing and they're making 2 of the 2 pieces, 2 binomials they would call it. And how they did that was they made an x, and then they put the last number, the 12, on top, the -7 at the bottom, the middle number, and then they asked what 2 numbers multiplied to give you positive 12 but add up to give you a -7. So you're going to need both negatives because it's going to multiply to give you a positive, and add to give you negative means they're both going to be negative. So -4 and -3. That's how they got these 2 numbers in the factors. Then you want to ask what is going to make this parenthesis 0, and that's going to be your 3 answer. And what's going to make that parenthesis 0, and that's going to be your 4 answer. So 3 and 4 are your 2 solutions. So that's how they did the factoring ones. The second kind that's on here is a square root method, where you simply have to get the little square by itself. So the little square is on it by itself. There's nothing like added or subtracted, or whatever. There's just the square. So what you can do then is you can square root both sides, because the square root cancels out the square, and you'll have just the x minus 7 come out. And then since you're square rooting, you have to use the plus or minus, because positive 4 squared is 16 and negative 4 squared is also positive 16. And then you get 2 solutions. You get 7 plus 4, and you get 7 minus 4. That's how they got these 2 answers here, 11 and 3. Your third method is completing the square. Now, it's kind of a little extension to the second one. You are going to end up square rooting both sides. So way down here, they square rooted both sides, just like you did in this problem over there. But you have to do something first so that you can square root both sides, and you have to complete the perfect square. So first you're going to get rid of that 8. You're going to move the 8 to the other side by doing -8. Now here they added 9 to both sides. Okay, it's okay to add to both sides. It'll stay equal. But the question was, how did they get that 9? So here's what they did. They took this -6. They took the -6 and they cut it in half, and they got -3. And then they square rooted -3, or squared it. They squared -3. -3 times -3 is 9. What that did is it made a perfect square trinomial. X squared minus 6x plus 9 is a perfect square. It's simply x minus 3 squared. So whatever you get inside of here when you cut it in half, that's going to be the same number that goes inside your square. And then they square rooted both sides. Again, they got their 2 answers of 3 plus 1 and 3 minus 1. That's how they got the 4 and the 2 there. This only works if this is an even number. I mean, it doesn't only work. It will work on an odd number. It'll just be a really messy fraction. So I would only use completing the square if that middle term is even. The fourth method is our quadratic formula. So I would always label which one is A, which one is B. B is -6, and which one is C. And then if they've given you the quadratic formula, whoops, you can't see that. So hold on 1 second. There you go. Okay, so I would label A, B, and C here. A is 2, B is -6, and C is 1. And then you want to just plug them into the formula. Opposite of B, so you can see right up here, opposite of B. Negative B means opposite of B. So if B is -6, we want +6. plus or minus big square root, b squared would be negative 6 squared. Okay, negative 6 squared is going to be 36. So same as positive 6 squared, because you're squaring it's going to be positive no matter what. Minus 4 times a is 2 and c is 1. 2 and 1 there. And so when you solve it, you get 6 plus or minus radical 28. Because 36 minus 8 is 28. Now they did take the radical 28 and they broke it into two pieces, radical 4 and radical 7, because 4 times 7 is 28. That's how they got the 2 and the radical 7. Then they reduced. So you reduce to get this answer, because you can divide all of them by 2. You can cut all those in half and you get 3, 1, and 2. So that's all they did there, is they reduced those three numbers. The last method is your graphing method. And you can see they've looked for this negative b over 2a, which actually equals the x coordinate of your vertex. So negative b, opposite of b would be 8 over 2 times 1. So you're going to get a 4. So that vertex is going to have an x value of 4. Okay, so this is going to be your x value. You can also use it as your axis of symmetry. X equals 4 is your axis of symmetry. Okay, so that would be your x equals 4 there. I know you can't see that, so let's go back there again. Okay, so let's recap. So the negative b over 2a you get as your vertex, your x number in your vertex, 4. And that 4 is right here, and so it's the vertex is 4, negative 1. That's your axis of symmetry. If you plug in that 4 right there and solve it, you'll get your y value, which you get as negative 1. When you graph it, you're going to get the two numbers that are on the x-axis. Those are called your roots. Okay, because you have the 0.30 and the 0.50, and that's how they got their two answers, 3 and 5. So wherever the graph touches the x-axis, those are your solutions. Negative b over 2a gets you your vertex right there. All right, so let's put these to use. So here are the 5 examples. They want you to choose one method for each one and use all 5 methods. So in the first one, they chose the square root method. And they just square rooted both sides. So they did the square root on here and the square root there. And you can see the x minus 3 just came out. And then it's plus or minus 7. So they added 3 to both sides. And they did 3 plus 7 and 3 minus 7 to get their two solutions there. Okay, so that's the first one. Second one, they used the quadratic formula. So they rewrote the quadratic formula. Okay, and then you have a is 5, b is negative 3, and c is 2. And so they plugged in opposite of negative 3 is positive 3 right there. And then b squared is 9, because negative 3 squared is 9. Minus 4 times 5 times 2. You'd get 20 times 2 is 40. That's how they got the 40 in there. And then this one you can't reduce, and it's actually a negative in here, negative 31. So that comes out as an imaginary number there. So that's where they put the I. That negative comes out as an I. So that was 2. The third one, they used the completing the square method, and the b was even, so that really helped. So if you took negative 12 and divided it by 2, you got your negative 6, which is what went into your parentheses for your completing the square. And so 6 squared was 36, so they're adding that to both sides. So to get what you're adding onto both sides, you're going to take the negative 12 divided by 2, which is negative 6, and you're going to square that number. And that's going to go on both sides of the equation. That number also goes inside the parentheses, and then you can square root both sides. And again, I didn't let you see it. I'm sorry. Okay, so recap. So your middle term is even, negative 12. And then you get negative 12 divided by 2, you get negative 6. Negative 6 squared gives us the 36 that we're going to add to both sides. And now that made this trinomial a perfect square. So the negative 6 is going to be the square root that you can bring out. So this negative 6 that you got goes in the parentheses, and then we square root both sides. So you get 6 plus 7 and 6 minus 7. Because square root of 49 is 7. That's how they got the 13 and the negative 1. That was 3. Okay, let's look at 4 and 5. We'll leave that like that. Okay, so number 4, they use the factoring method. Now this one's a little different because you got to get it equal to 0 first. So that's what they did there. And then this one has a number in front. And you can see it's got that 5 in front. So we actually needed a star instead of an X. And you're going to multiply these first and last numbers and get negative 40. And that's going to be what we multiply to. Negative 18 is your middle number. That goes at the bottom. The 5x goes at the top of the two sides because that's your beginning. And then two numbers that would multiply to give us negative 40 and add up to negative 18. They're going to have to be different signs. The bigger one's got to be negative. I'm thinking negative 20 and positive 2. Negative 20 times 2 is negative 40, and negative 20 plus 2 is negative 18, because you got to subtract them when they're different. And now you can reduce these two fractions. Make that a 1 and a 4. 5 over 2 cannot be reduced. So x minus 4 is one parentheses, which you see right here. X is on top and negative 4 is at the bottom. Your other parentheses is right here, 5x plus 2. And you set them both equal to 0 and solve it. 5x minus or plus 2 equals 0. You would subtract 2 and get 5x equals negative 2. And then you divide by 5 on both sides. You get negative 2/5. That's how they got this answer there. And then 4 would go in and make that a 0. So you want to know what's going to make this a 0. It's going to be a 4. So there are your two solutions for number 4. And then number 5 is our graphing. So I would have just typed this into Desmos, and I would have seen that the graph touches here at negative 1 and right here at positive 3. So this point is negative 1, 0. This point is 3, 0. So your two solutions are 3 and negative 1, where it touches. Your vertex is down here at the bottom at negative 1. Positive 1, negative 4. So if you needed your vertex, you could find that by doing opposite of b over 2a. That would get you your vertex. Opposite of b would be a 2 over 2 times 1, which is a 2. So 2 divided by 2 is a 1. That means your axis of symmetry is at 1, and it definitely was, because that's where the vertex was located. And then you can plug in that 1 and you get the negative 4 for your x or your y value. But I would say graphing is the easiest if you have a graphing calculator. You could just type that straight into Desmos, and you can actually see your graph. You'll see the two roots wherever it touches the x-axis. If it doesn't touch the x-axis, there's no solutions. So that's how that works. All right, there's your video notes for 3.1. Use these video notes to help you with practice A, the next assignment. That should be of help. You might need different methods here, so use all the different methods. Watch them over again if you need to get familiar with them.